we're going to answer the question, how can I make it a perfect square? We're going to start by reading page 17 first because there's a math notes down at the bottom. And it's regarding something called perfect square form of a quadratic. When a quadratic equation is written in the form x minus some number squared equal to some number. They're putting a p and a q there just to represent some number. Remember yesterday we had a number here and a number here, such as the one below. We say it is in perfect square form. Notice that when the quadratic expression on the left side of the equation below is built with tiles, it forms a square. Not a rectangle, a perfect square. All right. It's a perfect square because nothing is being added or subtracted to this perfect square, and nothing is being multiplied or nothing is dividing this perfect square. If either of those two operations are happening, you need to do the inverse operation to get that quantity squared by itself. Okay, that's what makes it in perfect square form. All right, go ahead and turn back over to the top of page 16. We're going to look at question number 71. Question number 71 says, solve the two equations below. Be ready to share your methods with the class. So for part A, they want us to take the equation x squared plus 4x plus 1 set equal to 0. The only way at this point in the chapter that you know how to solve this is to graph it in Desmos. We're going to learn later in the chapter something called the quadratic formula, and you will be able to solve this without graphing it. But for now, you would graph this in Desmos. It would cross the x-axis in two places, and you would take your little pointer and you would hover over those 2 points, what we call the x-intercepts, and it would give you these crazy decimals, this crazy decimal and this crazy decimal. Believe it or not, those are even longer decimals. That's just rounding them. Okay, they would be what we call irrational, and they would go on and on and on, and they wouldn't repeat. They're crazy. Okay, so that means the two solutions would be at negative 3.732 and at negative 0.268. Okay. Part B looks very similar, but it's in what we call factor form. It's even in perfect square form. So when you have perfect square form, you're going to square root both sides because that's the inverse operation. So when you square root the left side, you're left with the inside, which is x plus 2. And when you square root the right side, you're going to get plus or minus the square root of 3, which is this decimal. You take your calculator and you type in the square root of 3, you're going to get a bunch of numbers, but you're going to round it to 1.73. You want to do the inverse operation of this adding 2, which is to subtract 2 from both sides, and then you end up with two answers. You end up with negative 2 plus 1.73, which is this second answer right here, negative 0.27. And you end up with negative 2 minus 1.73, which will get you negative 3.73. Do not try and do that in your head, right? I can't even do that in my head. You're going to use your calculator. If you don't have your own personal handheld calculator, you just want to use the Desmos scientific calculator. Or Google scientific calculator, and whatever comes up, you're going to get a calculator. Or use your phone. You've got a calculator in there if you're at home, okay? You're just going to use a calculator. There's no way you can do that in your head, okay? Any questions on problem 71? All right, problem 72 says, with your team, and then with the class, you're going to discuss the following questions. You're going to examine the solutions to the first problem, x squared plus 4x plus 1 equals 0, and the second problem, x plus 2 squared equals 3, and see, what do you notice? What do your observations tell you about the two equations? Well, if you look carefully at the answers, you're going to notice that they're the same. We have this one right here is the same as that first one right there, and that one right there is that one right there. We're just rounded it to a different spot, okay? How can we get them the same? We could take the second one and we could expand it, or from what you guys know so far, you could technically graph both of those in Desmos and they would land on top of each other. They would be the exact same graph on top of each other. All right? So for part B, it wants you to compare the solution methods you used for problem 71 and what are the disadvantages of each method. So you're going to write, I prefer the one on the left, or I prefer the one on the right. And then you're going to write because, and you're going to say why you prefer it. I prefer blank because blank. You fill it in. Okay? I prefer this one, or I prefer that one because of whatever your reason is that you prefer it. I can't tell you why you prefer something. I can tell you why I prefer something, but I can't tell you why you prefer something. Okay? Question number 73, down at the bottom, is titled Completing the Square. With your team, examine the two different equations from problem 71 that can be represented using algebra tiles as shown below. Then answer the questions in part A and B. Okay? So we're going to look at these little diagrams they did with the algebra tiles. And we're going to notice that this one and this one are almost the same, but not quite. What's the one little difference between the left and the right? Anybody see it? This one on the left has these three pieces missing, right? Whereas this one on the right has the three pieces built in, but three extra over there. So what can be done to the equation on the left that will result in the equation on the right? You could add 3 to both sides, right? If we added 3 here, that would give us 3 there. Then they would be the same. They're almost the same. They're just missing that 3. Then you would rewrite it as a product. Okay? What does this change do? This changing a quadratic equation into perfect square form is known as completing the square. If you have a highlighter, highlight it. If you don't have a highlighter, circle it and put a star by it. This is a very important concept. And why is this name appropriate? Because you must add tiles to make the complete square. And it makes it a perfect square. Okay? Not a rectangle, but a square. Is anybody still writing? No. Yes? Raise your hand if you're still writing. Nope. All right, flip over to the top of page 17. You're welcome. You too, thank you. All right, for question number 74, it says, use what you learned in problem 73 to rewrite the quadratic equations below in perfect square form. Then solve the resulting quadratic equations and write your answers in both exact and approximate forms. Okay, let me move it just slightly this way. There we go. Oh no, I might need to just right there. Okay, trying to get a good view. All right, so we're going to do problem A first. Problem A is x squared plus 6x plus 5 set equal to 0. Notice that if you look at the algebra tile drawing, we are missing 1, 2, 3, 4 tiles over there. So that would give perfect square if we had 4 more. So right now we have 5, but if we added 9 to that, that would give us the 4 that we're missing, okay? Then we would be able to write what's called a perfect square trinomial. What makes it perfect is this 9. What times itself is 9? 3. 3 times 3 is 9. What is 3 plus 3? 6. Okay? So if you multiply 3, you get 9. If you add the 2 3s, you get 6. That makes this trinomial perfect. Okay? So x squared plus 6x plus 9 factors to x plus 3 times x plus 3, which we write as x plus 3 squared. Then we need to take this 5, subtract it. Then we need to take this 9 and add it. And then the negative 5 and the 9 combine to get the 4. Okay? Then it is in what we call our perfect square form, which is what we looked at yesterday and what we've just been looking at over and over. So we're going to take the square root of both sides, which gives us what's inside on the left. And on the right, we take the square root of 4, which is 2, but it's also negative 2. And then we subtract the 3 from both sides. And that's how we get our 2 answers. Our first answer is negative 3 plus 2, which is negative 1. And our second answer is negative 3 minus 2, which is negative 5. Okay? Part B is done the same way. We just end up with a decimal answer instead of a nice, pretty answer. Okay? So we're going to take the 2. We need to take half of it, which is 1. And then 1 squared is 1. So to make this a perfect square trinomial, there should be a 1 there instead of the negative 5. So we take that negative 5 and add it over to this side. Then we combine the 5 and the 1 to get 6. Now it's in perfect square form. Okay? Once you have it in perfect square form, then you do your inverse operations. You take the square root. You take the square root of x plus 1 squared. You just get x plus 1. And if you take the square root of 6, you're going to get plus or minus the square root of 6. Then, since your answer is going to be decimal, you definitely want to do this on your calculator, not in your head. So let me show you how to get both of those answers. So we're going to type in the calculator, negative 1 plus the square root of 6. That gets us this big, long decimal, which they don't want us to write the big, long decimal. They want us to round it. So that's why we use the wavy equal sign, and we round it to 1.45. Then we need to do negative 1 minus the square root of 6. Negative 1 minus the square root of 6. And again, it gives us another big, long decimal. You don't write the whole thing. You're going to round it to 2 decimal places. So it should be negative 3.45. Okay? You have to have a calculator for that. I can't even do it in my head. Okay? I have to use a calculator for that because I don't memorize the square root of 6. You want to memorize the square root of 6? Go for it. Okay? Any questions on number 74? All right, we're going to do one more together. And then the last one you're going to do in your group of 4. All right, question number 75 says, you can't use algebra tiles to write them if you want, but they just want us to do it. So we're going to take that middle term of 4, divide it by 2 to get 2, and then 2 squared is 4, which means our perfect trinomial is x squared plus 4x plus 4, because 2 times 2 is 4, and 2 plus 2 is 4. So we need to take that 5, add it to the other side, and then also add the 4 that we added over there. So 5 plus 4 is 9. We like 9 because it's going to have a nice, pretty square root. Okay?